Students, welcome to our YouTube channel Experience Tutor. Today we'll start with IIT JEE Physics Numerical Electricity Part 1. Before we begin, we have a humble request. Please subscribe, like and share our YouTube channel among your friends and relatives. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Okay, let us begin the chapter. Initially, we'll go through few of the important concepts, not the whole concepts, not all the concepts. We'll go through few of the concepts, then we'll do numericals. Again, we'll do few of the concepts, then we'll do the numericals. So, first is current and current density. So, what is current? Current is the amount of charge flowing through a specific area per unit time. So, if we want to interpret current as I, then d I is equal to dq upon dt. The SI unit of current is ampere. So, by definition, 1 ampere is equal to 1 coulomb per second. Now, now the current I through a area A depends on the concentration N and charge Q of the charge carrier, as well as the magnitude of the derived velocity Vd. So we can write I is equal to N, the magnitude of Q, the charge, Vd, derived velocity, and area of cross section. This whole term till here, NQVd, is known as charge density. It is a vector quantity. So charge density, we can write N Q V D. Direct velocity is also a vector quantity. The current density is current per unit cross-sectional area. So other way also we can write that current through cross-sectional area. Current is usually described in the term of flow of positive charge, even when the charge are actually negative or both sign. Now let us see the next concept. Resistivity. Resistivity. So what is resistivity? The resistivity rho of a material is the ratio of the magnitude of electric field and current density. So resistivity rho can be represented as the electric field E and current density. Good conductors have small resistivity. Good insulators have large resistivity. Ohm's law, obeyed approximately by many materials, state that resistivity rho is the constant independent of the value of E. Resistivity usually increases with the temperature. For small temperature changes, this variation is represented approximately by the equation rho T is equal to rho naught 1 plus alpha T minus T naught, where alpha is the coefficient of resistivity. So alpha is equal to coefficient of resistivity. Now, if we want to draw a graph, so if we want to draw a graph between T and resistivity rho, then we can see that the slope is equal to rho naught alpha, where alpha is the coefficient of resistivity. So, and here for metal, rho increases with increasing T. Rho increases with increasing T. This is the main fact we have to remember for metals. Now, next concept, resistor. So what is resistor? The potential difference V across a simple circuit or across a sample of material that obeys Ohm's law is proportional to the current passing through that sample. So, according to Ohm's law, if we want to write, then we can write V is directly proportional to I. Then we can write V is equal to I R. This R is nothing, the proportionality constant. So we have removed the proportional, so we have put equal to and a proportionality constant. This R is equal to potential difference upon electric current. So the SI unit of the resistance is also known as the ratio of potential difference and electric current. The SI unit of resistance is ohm. SI unit is ohm. 1 ohm is equal to 1 volt upon ampere. So uh, when upon 1 ampere, so when electric current of 1 ampere is passed through a potential difference of 1 volt, then the resistance of that conductor or of that material is known as 1 ohm. The resistance of a cylindrical conductor is related to resistivity, length and cross-sectional area. So we can define the resistance also by R is equal to rho into L by A, where R is the resistance, rho is the resistivity, L is equal to length of the conductor and A is the cross-sectional area of the conductor. Next concept is EMF. Electromotive force. So a complete circuit has a continuous current carrying path. A complete circuit carrying a steady current must contain a source of electromotive force. So if a circuit carries a current, the source is EMF. So let EMF is denoted by E. Then every real source of EMF have some internal resistance. So internal resistance is denoted by R, and in that case the terminal potential difference depends on the current. So VAB, say it is the terminal potential difference. So VAB we can write as E, the EMF, minus the current in the circuit and the internal resistance of the source. So this is the value of terminal voltage where EMF is used. Now, next concept is energy and power in a circuit. So, here say a circuit element puts energy into the circuit if the current direction is from lower to higher potential in a device, and it takes energy out of the circuit if the current is opposite. The power P equal to the product of potential difference and I, that is current. So P is equal to power is equal to potential difference and I multiply by I. So we can also write, instead of V we can write IR, so it will be I square R, that is equal to VAB square upon R. So VAB is just the potential difference and R is the resistance of that circuit. So power can be represented in these many forms. Now the next concept, conduction in metals. In a metal, current is due to the motion of electrons. They move freely through the metallic crystal but collide with positive ions. In a crude classical model of this motion, the resistivity of the material can be related to the electron mass, charge, speed of random motion, density, and mean free time between the collision. So we can write resistivity is equal to M. There is a relation: mass of the electron, number of electrons, E square the charge of the electron, and tau, density of the electron. So this is the relation. We'll not go through more concepts now. Just to build up some interest, let us solve few numericals based on these concepts. Then again we'll, in the next topic, we'll see few of the concepts. Again we'll go for numericals based on those concepts. So let us solve our first example. A silver wire 2.6 millimeter in diameter transfers a charge of 420 coulomb in 80 minutes. Silver contains 5.8 multiplied by 10 to the power 28 free electrons per cubic meter. Now we have to find what is the current in the wire B. What is the magnitude of the drift velocity of the electron in the wire? So this is quite simple, directly based on our concept. We have included this numerical because to get clear idea of the concept. Of course, IIT's questions will be more uh, critical or more mm, difficult in a simple word than this. But to solve those numericals, your concepts should be clear. So initially, we'll introduce with simple numericals, which clears the concept. So in our case, the current in the wire. So simple formula. What is the relation between the current and charge? So we can write A. What all things are given, we can write it here. So what is given to us? The diameter is given to us, right? D is equal to 2.6 millimeter. We'll convert into radius. So radius is equal to 1.6 into 10 to the power minus 3 meter. That is radius. Now what is given? What else? So Q is given to us. We can write Q, the charge 420 coulomb. Time is given to us, that is T is equal to 80 minute. So we can write 80 minute is equal to 80 into 60, that is 4800 seconds. We are also given n number of electrons per cubic meter is 5.8 into 10 to the power 28. So these all things are known to us. Now for A, we can write I is equal to Q by T. So Q is 420 coulomb upon 4800 seconds, which is equal to 8.75 10 to the power minus 2 ampere. So this is the value of the current. Now B, we need to find the drift velocity. So we know in our concept we have read this one. I is equal to N magnitude of Q, that is charge, and drift velocity multiplied by A. So drift velocity will be equal to I upon N magnitude of Q and A. Put all these values. So if we put all the value, 8.75 10 to the power minus 2a, just in part A we have found this value of current, and n is already given to us, that is here n's value is given. So 5.8 multiplied by 10 to the power 28 multiply by magnitude of Q is given to us, that is 420. Here magnitude of Q will not consider this. This is the charge of the electron. So they are talking about electrons. So charge of the electron is 1.6 into 10 to the power minus 19. So here there is a trick. So this is the charge of the electron. They are talking about electron. So charge of the electron will take here. Now multiply by pi r square. Pi is area. Area is pi r square. So pi is 22 by 7 multiply by 1.3 into 10 to the power minus 3. Minus 3's whole square. So this is the value of radius we have found here. Radius is equal to this, and pi r square we have put the value. Now upon solving we'll get 1.78 multiplied by 10 to the power minus 6 meter per second. This is the value of drift velocity of the electron. So our next example is the current in a wire varies with time according to the relationship I is equal to 55A minus 0.65A per second square t square. How many coulombs of charge pass a cross section of the wire in time interval between t is equal to 0 and t is equal to 8 seconds. B. What constant current would transport the same charge in the time interval? So let us see the solution. Our solution will be based on the equation given. So A, we know that dq is equal to I dt. Now q, therefore if we want to write q is equal to from 0 to 8, to find out the charge, lower limit will be 0 and upper limit will be 8, and I'll write the equation given, that is 55A minus 0.65A t square. So we can give a bracket here, t square, then dt. So instead of q we have put the value here now, and the time interval is put as a lower and upper limit. So upon integrating we got 55A t minus 0.217 A upon s square tq, and here are the limits. So upon solving the integration, so dt's integration is t, and t square's integration is t by 3, In that way we solve it, and now we can write Q as 55A multiplied by 8 minus 0.217 A S square 8.0 S Q, which is equal to 330 coulomb. Solving it and putting the 8 and 0 in the equations as a lower and upper limit, we get 330 coulombs. Now our next question is, we have to find the electric the value of current, that is I is equal to Q upon T. So Q is 330 coulomb, here we have found, and T is 8 seconds. So 8 minus 0, that is 8 seconds. So upon solving we get 41 ampere. And this is the answer for B. This is the answer for A. Let us see the next question. So the next question is, a ductile metal wire has a resistance R. What will be the resistance if this wire is termed to R? If in terms of R, what will be the resistance of the wire in terms of R if it is stressed to 3 times its original length, assuming that the density and resistivity of the material do not change when the wire is stressed. So we can write resistance R is equal to rho L by A. This we have learned in the concept. So and L is equal to new length. L is equal to 3 into L, the original length. The volume of the wire remains the same when it is stressed. There is no change in volume. So we can write the old volume is equal to L multiplied by A. So again it is equal to L new multiplied by A new. The area of cross-section area also cross-sectional area of the wire will also get changed. So we can write again as or here we can write A new will be equal to L multiplied by A upon L new from this relation. If we put the values, for example L new from here as 3L, then this gets cancelled and the answer the remaining is A by 3. A nu is equal to A by 3. So write it, A nu is equal to A by 3. We got a relation. Now R nu we can write as rho L nu upon A nu, which is equal to rho 3L. Instead of L nu we'll write 3L. Instead of A nu we'll write A by 3. So upon solving we get rho 9 rho L by A. Instead of this whole thing we can write R. So 9R. So we got that resistance will be increased by 9 times. This question is very important for the objectives. Multiple choice questions either in NEET or other engineering or medical examinations or IIT. Let us see the next question. So our next problem is, what diameter must a copper wire have if its resistance is to be the same as that of equal length of aluminum wire with diameter 3.26 millimeter? So this question is little tricky. First we need to find out the relation between resistivity, cross section area and resistance. So we know R is equal to rho L by A. We can write it rho L by in terms of diameter. So in terms of diameter we can write by 4. So for aluminium, for aluminium the resistivity AL will be given to you in the question paper. No need to mug up or remember. It will be given 2.63 10 to the power minus 8 ohm meter. For copper also it will be given, it will be 1.72 into 10 to the power minus 8 ohm meter. Therefore we can write rho by d square is equal to r pi by 4l is equal to a constant. From where we got this value? From this equation we got. From this equation we got. If we solve it, we will get this value, and this is constant. So in this case, we can write rho aluminum, resistivity of aluminum upon resistivity of copper will be equal to resistivity of aluminum upon uh, diameter of aluminum square, and resistivity of copper upon diameter of copper square. So we can write, we have to find diameter of copper. In that case, we can write diameter of aluminum under root resistivity of copper upon resistivity of aluminum. Now putting the values, we'll get 3.26 millimeter under root resistivity of the copper is 1.72 10 to the power minus 8 ohm meter, 2.63 into 10 to the power minus 8 ohm meter is equal to 2.64 millimeter. So this is the answer. So let us see the solution again. First we have put R is equal to rho into L by A, and A, the area of cross section, we have written in terms of diameter, so pi d square by 4. So a rho's resistivity of aluminum is given, resistivity of copper is given. Here we found rho by d square is equal to uh, r pi upon 4L, which is a constant. So rho of aluminum, the resistivity of aluminum and diameter square is equal to resistivity of copper and copper's diameter square. So diameter of copper is equal to diameter of aluminum under root, by cross multiplying it we can find this thing. So and under root rho of copper upon rho of aluminum. Just putting the values, we get the diameter of copper is equal to 2.64. And this is the end of today's class. Please subscribe, like and share our YouTube channel. Please click on the subscribe button to support us, and please click on the bell icon to get notification whenever a new video is uploaded by us. This video, if you like this video, please click on the like button so that I could get an impression that okay, this video has benefited you. Thank you for your support and watching these videos. Thank you very much.